right, flip side to 0.2, looking at the multiple representations here. In this scenario, I'm taking a look, and I have myself a table. Now, this is a weird table, just because usually, or at least what we're used to reading, is using it kind of like looking at it vertically speaking. This, however, is taking a look at it in a horizontal method, so a little weird, but just take our time when we read this. When we see f of x, remember it is interchangeable with y, so if you like thinking about f of x as a y value, how would this thing appear on a graph? That might help you out. Always to put the y next to the f of x. That's certainly something that you can do. I like to take a moment and highlight certain things, right? So whenever I see an x value, letting myself know, hey, this is where I have x's in the problem, my domain, my input, and then of course taking a look and figuring out, hey, where are my y values as well, right? So that's certainly something that is helpful as well. All right, so let's go ahead and answer these questions. We have table of values. We also have some things written in function notation, not a full equation, but some things in function notation as well. So the first question here is taking a look at an x value of -3. We need to go ahead and figure that out. What is its corresponding y value? Well, right here I see my x value of -3. What is the y value for that? The y value is the number 2. So pretty simple right there in terms of understanding how to use the table. Same thing plays out for the 20. We know that the x value here, what's inside the parentheses, the input is 20. What is its corresponding y value? And of course that would be 0. I'll take a moment with those two problems to write them out as points, just because we know we have multiple representations, and we could at some point put this onto a graph. A quick note about 20 comma 0, we see that the 0 is our y value. When we have a y value of 0, we know that that is in fact a x-intercept, which is a pretty big deal within the context of this whole course, so we want to just keep on getting the reps on that. The big difference here in these problems that we have to be focused on is looking at something that is phrased. I'll take a moment here to erase this for a second. Look at how these are kind of positioned in terms of the questions, right? Those things are different phrases where we're told in this problem, here's the x. And here in this problem, we're asked, what is the x? So just understand that when I get to the bottom section here, I'm being asked something different, right? I'm being asked, what is x? And so in this situation here, I know that I am told that my y value is 9. So in this scenario here, I have a y value. Y value is 9. In my graph, the y value is 9 right there. What is its corresponding x? I've kind of flipped around the way this is being asked of me. And the corresponding x is right there. So my x value is 2. And then this last one gets a little tricky. We are given a y value, and the y value is 4. Well, check this out, because you take a look here. There's actually 2 y values of 4. So I want to make sure I look at the full table when I'm answering these questions. So I actually have 2 separate answers. I have an answer where I have an x value of 9, and I have an x value of 8. both of those x values have y values that lead to the number 4. So when I write these points out, understand that, again, it's x comma y, but in this scenario, for this last problem, I actually have 2 locations that have a y value of 4. That's using a table to kind of break down problems. Of course, understanding the function notation at the beginning and what's being asked of me is super important in these problems.